Dino Another Day. This is Amr Thamin, this is Jack Donovan, I'm Tybee Kantrowitz. And
All right. Hi, everybody. So as was said, we were pursuing the data visualization category. And it was a very open-ended data set, so we really had full reign to decide what we were going to use with this data and how we were going to represent it. So what better issue to tackle than this question of how do paleontologists decide where to dig? You know, it's sort of like a poker game in that there are a lot of things that you know and there are a lot of things that you don't. So it's really important to figure out what data would help paleontologists validate their plans when they're pitching them to receive grants that would enable them to go to these sites in the first place. So, with that in mind, we had these objectives, which is to get paleontologists money more easily, and also, think of a way to present this data in an intuitive way and visualize it in the way that would best convey the importance and the significance of the data. And so enter NextDig, this app that we created, and it's a tool that helps scientists make educated guesses about the location of their next dig and visualize previously collected data in virtual reality. So why virtual reality? Why not just use a normal computer, a mobile phone app? Well, what if every time you tried to convince someone of something, you could make a museum exhibit about it? That's what virtual reality gives you, because instead of a computer screen, you have an entire virtual world with limitless three-dimensional space to convey your data in a way that's not only efficient, but it's also intuitive. So the data that we used is the paleobiology database, which is this huge database of all these different fossil records, latitude, longitude, stratigraphy, geographic clusters. We had a wealth of data to work with, and with virtual reality, we had the space to convey it. So this is how it works. We have these three-dimensional visual representations, like this globe. And when the user interacts with the globe by clicking a point on it, that data is translated into latitude and longitudinal data, and it's used as the parameters in the query to the API. So everything you do in virtual reality is contextualized as a way to get information back. The data is downloaded and parsed by type, so a series of points might become a graph automatically, or a topographical map might become a three-dimensional representation on top of a table.
so that was just a sort of a simple version of what we've got planned. So what would happen next? Well, imagine if you could swim through the layers of data, and if you could pull in weather data as well as the stratigraphic data, the climate data, so that all of these things would combine and you could get an intuitive understanding of, well, if we found fossils over here, well then maybe in this area over here in the world, there might be fossils, and a paleontologist, when they're writing a grant, could take this as part of their presentation to somebody who might fund them and say, well, this is why we want to go to that location. Give us your money. So that's part of what this helps them do. So thank you very much.
And as a last point, obviously we can't convey virtual reality to you all on this screen, but if you find us, we would be happy to give you a demo using this VR headset.